this demo for ANOVA is exactly the same file, I hope. We're going to double click on it, open it, and hopefully that SPSS will open up. You guys can download it in the meantime and open it in SPSS. It's not there? I can put it up right now. I uploaded them from this. I would have thought it would have been there, but I'll check that right now. I will check that now. Okay, Blackboard. Okay. Have sections. Okay, analysis of variance. Okay. My goodness, you're right, it's not there. You know, I had 5 files there. I put one of those files in empty twice. Okay, browse. Oops, I gotta click down here and then click browse. Oops, wrong one. Desktop. Where is it? And say submit. Okay, you guys should be able to get to it now. I'll give you a minute to get the Blackboard and download it. Okay, let me see how these guys are doing online. Okay. Terrific. Population averages are equal. Not sure what that means, Danielle. Okay. Okay. Most of you guys there already? Okay, good. All right, I'm looking at the data view now. Remember with SPSS, we have a data view and we have a variable view. There are 2 variables here. Got 2 columns, there's 2 variables. Column 1 is I didn't make up a lot of these things. We make up a public health or biostatistics backstory for these things. I didn't make up a backstory, just names and numbers. Okay, I just called the variable measurement. That's a numerical variable. It's a number of some kind. It could be blood pressure, it could be blood sugar, it could be any of a number, enzymes, whatever. But it's a number, numerical variable. The group is a categorical variable, right? Because you want to break this up into groups. Could be male, female, could be a hair color, blonde, brunette, redhead, so on and so forth. It could be ethnicities and so on and so forth. But whatever, it's some variable. It's some categorical variable that has at least how many values? Would you say if we're using ANOVA? It has at least 3 values because otherwise we use a t-test. We wouldn't bother with ANOVA, right? So now, you want to know something interesting? If you want to play around sometime, take the take a numerical variable that you can split up into 2 groups, say male and female. Blood pressure is male and female, right? So you got male and female. You take the averages. Want to compare the averages? Use the t-test. As an experiment using SPSS, do the t-test and see what your result is. Then do it again with the same data using analysis of variance and see what you get. What would you expect to get for the probability of being able to reject the null hypothesis? What would you expect to get? You expect to get the same answer, right? You wouldn't bother to use analysis of variance. What's that? Yeah, you'd expect to get the same answer because analysis of variance will work just the same way with 2 groups as it does with 3 or 4 or 5. You just don't bother to use it for 2, right? In fact, if you really want to get a headache, you may be able to find a textbook or online an explanation that analysis of variance really, in a way, is the same thing as a t-test, right? But that'll really give you a headache, right? I would just do it at SPSS and demonstrate that you get exactly the same result. Okay. So analysis of variance we're using though because we don't want to introduce that extra error by doing those repeated t-tests over and over again. Okay, so let's do this analysis the way we would. You saw how painstaking it was just now when we did it in Excel, right? Wasn't that painful? But it's a simple data set, so could have been a lot more. Could have been a lot worse. So here's the variables. A categorical variable, which is like groups. If I change the view to if I turn off value labels, you can see that they're really numbers. One represent. I missed it there. One represents Fed, two represents Jim, and three represents Alice. If I turn off the value labels, you can see that buried in there. I'll leave the value labels turned on. The measurements don't change because those are numbers. If I look at it from the variable view, I can look at measurements. Actually, I can see that there's an error here. What kind of measurement is measurements? It's a scalar, right? Numerical variable. Sometimes, if that's not the right form, SPSS, what it does when you open a data file that hasn't been coded, it takes a guess at whether it's a scalar or a nominal variable. In this case, since the values were all small numbers like 1, 2, 3, 4, it kind of said, oh, maybe it's nominal. A lot of people use 1, 2, 3, 4, 5, for a nominal variable to represent different groups, right? But in this case, we straightened it out. It's scalar, right? Now you'll notice what has been categorized here is the values that are represented by the group variable. The group, 1 means Fred, 2 means Jim, 3 means Alice. So we have 3 groups here. So now, if I want, I'm going to go back to data view just for the hell of it. I don't have to do the analysis. First thing I'm going to do is take a look at our means. That's what we did. We calculated means before, right? Analyze, descriptive statistics. I'm going to go to explore. Okay, and I'm going to say, okay, the dependence list, I'm going to put measurement in the dependence list, which is the number that we're going to find the mean, that we're going to use to calculate the mean. I'm going to put fact in a group into the factor list. So we're factoring the groups into 3 groups. We're factoring results for the mean or the descriptive statistics into 3 groups, Alice, Fred, and Jim. So I'm going to go into statistics, calculate the descriptives, and use confidence is use 95%, so on and so forth. I'm going to just tell it to go ahead and do that. Okay, it automatically will draw plots for us. Okay, see what we get. We get 5 values for Fred, 5 values for Jim, 5 for Alice. The mean for Fred was 1.8. Mean for Jim was 3.4. Numbers sound familiar? Same thing we got in Excel, right? Alice was 4.4. Okay, let's see. That's all I'm going to play with right now. Let's look at the box plots. Whoa, very interesting here, right? There's a lot, Alice has a lot of variability, a bit more than I would have liked, right? And here's Fred over here. The ones that seem furthest apart are Fred and Alice. Jim and Alice, looks like it's going to be kind of tough to distinguish. Remember, we just did with the trees, right? The variability, the means. This is the median, not the mean, but we get the same idea. The means are not that far apart, and there's a lot of variability in there, so it's going to be tough to tell them apart. But Fred is really pretty far apart from Alice and Jim also, and a lot less variability. So maybe we're in pretty good shape here, with at least with Fred and Alice, maybe even with Fred and Jim as well. But we're going to find out. Take a look at this in a second. So now let's go back up to analyze. Okay, that was just, you don't have to do that to do your analysis of variance. I just wanted to take a look at the data. It's always nice to see the data plotted out. I didn't bother to do histogram. Well, I didn't five numbers. You might ask it to do histogram so you can see if the data looks normally distributed to you as well. Okay, so let's go to analyze. And where am I going to look for analysis of variance in here? Even though it's called analysis of variance, what are we really comparing? Means, right? So compare means, one-way analysis of variance. Okay, so I'm going to use measurements into my dependence list and group Alice, Jim, and Fred into my factors group. And I'm going to go ahead and run this. We're going to come back to this again. I'm just going to go ahead and run this and calculate the analysis of variance. What is my analysis of variance? What is F equal? Well, first of all, number 1. Let me see if I can't get that Excel file back up here. Let me see. Let me see. Did I close it without saving it? Oh, there it is. Okay. Let's see what we got here. Oops. Where's my output window? Here it is. Oh, okay. Let's see what I got here. How many degrees of freedom I have between groups? Well, first of all, sum of squares between groups is 17.2. Sum of squares between the sum of squares between the groups or between the means 17.2, same as we got. Sum of squares within the groups 25.2, 25.2, just like we got. Sum of square degrees of freedom 2 between the groups, 12 within the groups. What did we do to find the mean squares? The mean sum of squares? We divided the sum of squares by 2. 17.2 divided by 2 is 8.6. 25.2 divided by 12 degrees of freedom within the groups is equal to 2.1. And what did we do with that 8.6 and 2.1? We put 8.6 on top, 2.1 on the bottom, because we want F to be bigger if the means are further apart. And if the variability is small, we want it to be bigger, so we put that on the bottom. And we got 4.09 by dividing 2.1 into 8.6. And in fact, we do the same thing here. 8.6 divided by 2.1 gives us our F statistic, 5.095. Next step we did was we went to the table to find the critical value for F. We don't need that in SPSS because it has all those tables or calculations built in. And it told us the probability of being wrong if we reject the null hypothesis is 4.4%, less than 5%. So the big difference here is we actually have a number, a significance, a statistical significance, or a p-value for the probability of being incorrect if we reject the null hypothesis, which is 4.4%, where before we only knew that it was less than 5%, right? Because we exceeded the critical value. Well, now I have that problem again. Now I still haven't demonstrated that there is that which of these groups are different from one another. So that's where we're going to go with our post hoc test. Analyze. I'm going to go to compare means again, one-way analysis of variance. And this time I'm going to click into this little box that says post hoc. I have a plethora of various different post hoc tests. One of these is really kind of just simply taking these things and just, if there's three groups, just taking that 5% error that we're willing to accept, dividing it by 3 and forcing it to see if I can get that level of certainty between each one of the t-tests that I would do, right? Really simple way of looking at it. Levi, what do you recommend here? Which test do you think would be most rational? I I asked the wrong person. Most in a Yeah, okay. Or most people I know like to use Bonferroni or Tukey, right? Those in the past that seemed to be the two most popular ones I came across. Some of these are more conservative. The different calculations. Some are more conservative than others, right? Which one is the most conservative? LSD, Bonferroni. Okay, that's a more conservative test. All right. So in other words, if you're feeling, like that you want to be certain, you might use that as opposed to one of the others. So I'm going to use all three. So I'm going to say, okay, continue. And I'm going to say, okay, oops. Oh, I didn't move the values in here. Measurement. I've checked off all three. So it's, where we're using software that just makes you, click something to get, do a complicated calculation. Why not? So I'll say, okay. And my output window comes up and let's take a look at it. And now SPSS does something that's really kind of like silly here. If you look at this, I'm going to look at Tukey first. This is one type of post hoc test. It compares Fred to Jim and Fred to Alice. Then it compares Jim to Fred and Jim to Alice. Then it appears Alice to Fred and Jim and Alice to Fred. See, there's a duplicate in here, right? Fred to Jim is here and Jim to Fred. Comparing Fred to Jim and Jim to Fred is the same thing. So it does the test twice. What I'm really interested is this column here, the significance, right? The p-value, the probability of being wrong if I reject the null hypothesis that the mean for Fred is equal to the mean for Jim, I want to look at any place where that significance is less than 0.05. So the first place I see is right here when we're comparing Fred and Alice, right? That significance is less than 0.05. That leads me to believe I can reject the null hypothesis that the mean for Fred is equal to the mean for Alice. Those are different. Now, how about Jim and Fred? No way. How about Jim and Alice? No way. How about Alice and Fred? Well, we just did that. We did that over here with Fred and Alice. We didn't get that there. Alice and Fred, Alice and Jim. So the only one, oh, excuse me, I'm over here. Alice and Fred, same thing as Fred and Alice. So we know already we can reject the null hypothesis. Alice and Jim, well, no, we can't reject that null hypothesis either. So there's only one pair of these that we can say of these. What is it? Right? There's three groups. So it's 1 to 2 to 1 to 2, 1 to 3, and 2 to 3. There's three different pairs. Of the three pairs, three comparisons, there's only one that we can say with at the level of alpha is equal to 0.05 that the means are really different from one another. Let's see if we get the same results on the rest of them. LSD, Fred and Alice are different, none of the others are, right? Although we get a little bit closer here on Fred and Jim, right? So that's a little less. It's a little less conservative. And Bonferroni, again, we get one group that we can say that there's a difference, 0.05. Notice that the p-value here is closer to 0.05. We almost missed being able to say that they were different, at alpha equals 0.05, right? Because this happens to be a more conservative test, right? You were right, absolutely right. Yep, it's the closest to missing rejecting the null hypothesis. It was the largest p-value, right? So at any rate, so that's where we are, right? So we have a mechanism now for number one, taking large groups of data, lot of different groups together, and analyzing them together efficiently and effectively, and without introducing a lot of extra error by doing multiple t-tests. And we have post hoc tests that'll let us check to see that once we have determined that there is differences in there, where there isn't, if we hadn't rejected null, if we weren't able to reject the null hypothesis originally with analysis of variance with the F-score, then we wouldn't have bothered with the post hoc test because none of them would have come up rejecting the null hypothesis, saying that the means were different in comparisons between the groups. So we only run the post hoc test once we've gotten an F value that has a significance less than 0.05. So now you have data that you have at home from this from the city health survey, where you have some groups, ethnic groups, for instance, or different kinds of groups of people, whether it might be a group of, you have 5 groups for people's different views of their own health status, right? So you may want to look at maybe age, for instance, might be a interesting way to compare whether there's a difference in the average age for people who think that they have excellent health versus good health versus fair health versus poor health, right? Are the means going to be the same for them or different, right? Well, there a nominal variable has 5 values, and you have some numerical variable you can compare it to. That's just one. There's a lot of different data in there. So now you have a new test that you can look at new forms of data in there and evaluate it, rather than getting stuck with what you have up till now, up until this. All you have was a chi-square, and chi-square and odds ratio relative risk. They only work for categorical variables, not numerical variables. If you wanted to work with numerical variables in different groups, well, then you were stuck with the t-test up until now. Right now, you got another tool. Okay. Anybody, if you want, maybe you can pull that table up now and look through it and see if you can't find a couple of variables that you might want to analyze using analysis of variance. Okay. So what are you looking for? You're looking for a categorical variable that has more than 2 values, and you're looking for a numerical variable that you can compare the averages within those groups, within those value, within that categorical value variable. Okay, so I'll give you a chance, guys, to do that, and we'll, if you want, I can come over and like look over your shoulders and see if you're having any luck with that. And I think if you look under, I know it's in there. It's under the project, I guess. There's a full data set, right? You may have to do some coding, right? Because you may find that some of the categorical variables are not coded. In other words, you know that one is equal to this, two is equal, and you can look in the code book and see that one equals, I like, like I think I'm in excellent health. Three equals I think I'm in good health. Three equals I think I'm in average health, and so on and so forth. You might have to code that in, and where do you code that in? You code that in SPSS under the variables view. You go into your categorical variable, your nominal variable, you click on values, and you type in 1 equals excellent health, 2 equals good health, 3 equals, I'm not sure that these are really what the number, average health, and so on and so forth. Just like we typed in 1, 2, and 3 for Fred, Jim, and Alice here. Okay? So anybody got a question about this? It's not that mysterious, right? This analysis of variance stuff, once you kind of get an understanding of how it works.
That's like your way of saying once you understand it, it's easy.
No, but it kind of makes sense, right? I mean, it looks a little, bit, I don't know, looks a little complicated when you actually go through the math, when you actually try and do the calculation raw by hand. It can get a little bit confusing, but I mean the concept that this is the way you're going to determine whether these means are really different from each another based on the variability between how far the means apart, or variability between the means, and the variability within the whole group or within the groups, right? That concept makes sense, right? Like I said with the trees, when they're narrow, they don't have to be that far apart, the means. When they're wide, the means have to be further apart for you to be able to prove that they're really different from one another. Pull down the data set and let's work on it. We got about 15 minutes, I think. Let me see how things are going at home. Okay, how are you guys doing at home? Oh no, somebody asked me a question. Oh no, you're answering a question for me. Thank you very much. I appreciate it. Okay, you guys got questions at home? Okay. Let me see if I can't open up that data set myself. You can see me working on it. Oops, I don't want to do that. Let me get that data set open also. Well, like I said, these videos are on. Everything we did tonight is in those videos. Each one of them is only about 5 to 15 minutes long. So there's snippets. So if you want to go back through the Excel example and all that calculation, every step is in there. If you want to go through the SPSS example, every step is in there. And then the post hoc test, every step is in there. And for the same data. And if I'm lucky here, I can find the CHS data, Community Health Survey. I don't want to do that. Let me move this over here. Okay, I got the Community Health Survey up over here myself. And I'm going to go, this is the data view. I'm going to go into the variable view. And I'm going to look at the labels. Okay, so here here's a numerical variable I found pretty quickly. What's your age? Right? Everybody agree that's a numerical variable? Now I can find means for people's ages. So now I'm going to take a look at, let's see. This is a measure of depression, right? Question 5.6. During the past 30 days, How often did you feel worthless? Do you think now that's categorical the variable, right? Let's see what the values are for that. The values are coded in here already. Okay, the values are all of the time, most of the time, some of the time, a little of the time, none of the time. Do you think that the for average age for people that would say all of the time is different than the average age for people that would say none of the time? Think so? The average age, let's give it a try. Okay, we're going to compare. Our categorical variable is the level whether or not you feel worthless. 5 different categories of it, and we're going to look at the average age since that's a numerical variable. How am I going to do that? I'm going to go into analyze. You know what I'm going to do first? I'm going to go into analyze, descriptive statistics, explore. I want to see the average first. Okay, so the average in the numerical variable is was age, which was question 7.1. I think that was age, right? Well, okay, what is your age? And the factor list was 5.6. How often did you feel how often did you feel worthless? And that was categorical variable, right? Okay, so now I'm going to tell it to tell me the descriptive statistics for that. I'm also going to tell it to plot. Oh, it's going to plot stem and leaf. I'm going to tell it to plot histograms also, and I'm going to say okay. So let's look at this data. Always nice to look at the data before you go too far. Okay, let's take a look at it. What? Okay, all of the time, people have reported that they felt worthless all of the time over the past 30 days. The average age was 52.15. Most of the time, 53.41. Some of the time, 53.57. A little at a time, 51, a little younger. None of the time. Doesn't seem like they're very different, though, does it? Okay. Let's take a look and see if they're normally look pretty normally distributed, right? Pretty interesting, right? Let's look at the box plots. Look at the box plot. Oh, I don't think we're going to have much luck here telling them apart, right? Okay, let's do our analysis here. So we're just looking at the data. We're thinking we're not going to find a difference between any of these means. Analyze descriptive statistics, compare means rather, one-way analysis of variance. And again, I'm going to put the age into the dependence list, which was 7, I think 7.1. And I'm going to put in the category for feelings of worthlessness, which was 5.7. Put it in there. And I'm going to say, okay, what do I get for my F score? Right? That looked like, remember, this is more degrees of freedom, right? So we need a bigger number because more degrees of freedom. I'm not going to bother to look up what the critical value is. But the significance, is it less than 0.05? No. So I can't reject my null hypothesis that the average age for each one of these categories is the same. Can't reject it. So do I bother to run my postdoc test? No, I'm going to run it anyway just to see what I get. Analyze, compare means, one-way analysis of variance. I know it's a waste of time, but I'm going to run it. I'll run Bonferroni, click continue, and say okay. And it's going to do all the same analysis, except this time it's going to compare all of the time to most of the time, all of the time, some of the time, all the time. And it's going to do each one of them twice. And if I look at the significances, none of them are anywhere near 0.05, right, or smaller, right? I can't reject the null hypothesis. I didn't even bother. I really didn't have to bother to run post hoc tests. So you guys get a chance to go delve into this data and try and find something else that play around with it. That would make a nice project, right? And then you can step back a little bit, research it. You don't say, gee, what's the relationship that we know about, like that we think we know about. In this case, age and feelings of worthlessness or depression or whatever, and what factors you think might influence this, and so on and so forth. Okay. Has everybody picked a topic for their project? Or are you still working on that? Yeah. Okay, well now you got another tool now that you can use to analyze this data. Maybe there's something else in there you can tease out that's interesting. One of the things that you're going to have to do is that if you're going to use analysis of variance, a lot of this data is categorical variables. So if you want to use analysis of variance for the most part, you're going to have to find numerical variables in here too. Like I found age, right? Survey weight is not a person's weight. It's actually how they weighted the survey. So we are a little light. Up number of cigarettes smoked a day. That's you can calculate average number of cigarettes smoked a day. How about that? Let's compare the average number of cigarettes smoked a day compared to feelings of worthlessness. Right? That sounds like depressed people or anxious people might smoke more cigarettes. Right? So let's give that a try. Okay, so what is that? That's number, yeah, but I don't know how I'm going to find it. That's a pound sign. That's number per days. Okay, analyze, compare means, one-way analysis of variance. Okay, I'm going to leave the categories in there. Number per days. Actually, I'm looking at the label here, which is number sign. Anyway, number of cigarettes. What's that? That one? Yeah. Oh, good. Thank you, Daniela. Good work. You were ahead of me there. Okay. Actually, I saw that and took the credit for her. I didn't want to. I was hoping she wouldn't say anything. You didn't see that, and I could take the credit for that. Okay. So okay. Let's see what we get. Okay. All right. Oh, I had post hoc still turned on. Again, I'm out of luck, aren't I? Right. My F score comes out to be 0.802. I can't tell the difference between them. I wonder if that's true. Let me just see the descriptives on that. That didn't work out too well. That Daniela suggested that, not me. Let me go to explore, analyze, compare. I'll bet you're going to be able to tease out some of these that are going to work pretty well. Number of cigarettes. I want descriptive statistics, explore. I'm going to move this back. And I'm going to, I wonder if I got the right factor. And that number of cigarettes smoked. Number of cigarettes smoked. Okay. Statistics, okay. Okay. See what we get. Okay, the mean if you're worthless all of the time, 14.1 cigarettes per day. Most of the time, 12. Some of the time, it looks like me like it was. Maybe I got this wrong. Because it looks like as you smoke, the less depressed you are, anxious you are. It looks like you're smoking fewer. I wonder if I put the wrong variables in. Analyze, compare. Because the names are so similar. Let me see what I put in there. No, I put the wrong variable in. Let's get that out of here. And what was the one I wanted? That one. Oh, well, that's right. Should have been this one. Let's try this again. It's supposed. Oh, wow. Look at this. That one worked, right? Okay. And then when we do the post hoc test, the biggest difference is between all of the time and none of the time. So it appears that this would suggest that people that are depressed smoke more than people that are not depressed, right? And we have a couple of all of the time. You can reject the null hypothesis for all the time compared to little at a time and to none of the time, and so on and so forth. Okay, so that's pretty interesting. Not only that, but the other interesting thing that we saw here by looking at descriptive statistics is that we see a kind of a cause. We see a kind of a dose. What am I trying to say? A dose response relationship here. right? The more depressed they are, look at how the numbers go up. 8, well, 8, 6, 11, 12, and 14. We kind of see a dose response kind of relationship here as well, right? A little bit more evidence. Okay. So you guys can dig out more stuff. That's a nice project. That's Daniela's project. She owns that one. I got that wrong. You had a good idea there, and I moved the wrong variable in there because it's kind of confusing when you try and see them in that little box. Okay, so give it a try and a few more. There's more numerical variables in there. If you pin down if you can locate some more numerical variables, you may find some other good combinations to look at. I keep hitting the wrong button there. Okay, and you may notice that you got to make sure that these are right as well. Scalar, place of birth, country of birth is not really scale. That's really, see, so you got to be careful. Sometimes they're wrong. Like country of birth is not scalar. It just happens to be a number, and it thinks it's a scale. So, but it's really nominal, right? There's just so many numbers, so many different countries listed there that SPSS interpreted it as a number rather a numerical variable instead of a nominal variable. So you got to be a little bit careful there. You may even find some numerical variables that are classified as nominal, just like the one we worked with before, because it's a small number set, 1 through 5 instead of.
Say you want to make a comparison in one of those category nominal variables, but you have like 50 different options and you only want to look at a subset of them.
You could recode it into a new variable. Remember we did that last week? You could say that, let's say there's 50 different options there, and you only want to compare 5 or 6 of them, right? You could say, I want to, let's see, where is it? Transform, recode into different variables. And what am I going to do there? I'm going to take the variable that you have, move it in here, give the output variable a new name and label, right? I'm just going to pick one at random. Give it a new name and label, right? Name being the variable name, no spaces and so on. Label being a better, more expansive name for it. And then I click on old and new values and tell it that if the value in the old data set was 1, then the value in the new data set is 1. If the value in a new data set is 2, oh, I don't want that one. Don't give it a value, right? Just go on to 3 or 7 or 9, and it'll only move over the values that you've recoded, right? So you can build it into a lower set. You could also combine them, so that if it's a numerical variable, you want to change it into categorical variable. You could say, okay, if it's a test score, right? You could say, okay, 60 to 70 is a D. 70 to 80 is, so you can make any score between 60 and 70 is a 4. Any score between 70 and 80 is a 3. Any score between, and so on. You could recode a numerical variable in a categorical variable if you want to do like a chi-square or odds ratio and so on and so forth. Yeah, there you go. Yep, absolutely. And you can do that. I like to recode because then you got a nice separate, group of data and stuff like that. A little easier to replicate it later on if you want to figure out what you were doing. Okay, it's time to go home. It's 8:50, so hit the silk. Yes, you guys have nothing to do tonight. They have 24 is on now, and are the Nets playing the second round yet, or are the Nets in the second round yet?
Yeah, Wednesday.
Oh, Wednesday. Not playing tonight. Okay. Yeah, they're not going to last long against the Heat. I'm sorry. What's that? I grew up in Brooklyn. I'm in Queens. I hate to say I'm in Queens. I'm really a Brooklyn kid still.
Are you able to look at the data one from the hybrid? The data, are you able to send that one and give us some clues as to maybe like how you do this one?
I'm sorry. Which
The
data?
hybrid one from the home project.
Oh, I'm not sure which data that is. Well, this was the data here, right? The community health. Oh, I'm not sure. Levi put the, yeah, let's take a look. Here, look over my shoulder. Oh, let me close this out first. Okay, guys, online, Daniela, take care. Thank you for taking part, and we'll see you next time. Bye. I think she's gone already. I don't know. Let me see. Look in here. Uh, yeah, she's not online anymore.